Hi, everyone. Today, I'm going to talk about computer vision and how developers with no machine learning experience can still be able to add some cool features to their web app, mobile app, or even an IoT device. My name is Mena Salwans. I work as a software engineer at SPR. SPR is a consulting company. We have offices here in Chicago and Milwaukee. We're also an AWS partner. Feel free to connect with me on LinkedIn or send me an email if there's a question. I will also be available in Slack. So there's a notion that in order to add machine learning or any computer vision features to your app, you will have to be a data scientist or have a team of data scientists that will help you to build these models. But I'll show you today that we can use something like Rekognition service from AWS to recognize objects and images and also identify people. So first we'll go over a little bit of details and background about machine learning, how it works, and then we'll move to computer vision. We'll talk about some applications and examples, and finally we'll go to a demo. This should be interesting. So most people, when they think about machine learning, everyone knows artificial intelligence. So I wanted to differentiate between them quickly, so I'll make sure everyone on the same page. AI, we all heard about it, mostly in sci-fi science fiction movies, and when they represent the future, there is some robots and devices that can do tasks on its own with minimum or no human input at all. So that's exactly its definition. So AI, it's science of building a device that will react as a human on its own. And the problem here, devices are not smart. So that's how we have to program everything and tell it what to do. And here where machine learning shines. So using machine learning, we can teach this device or this machine to make it learn using a certain set of data, labeled data or not. And after that learning, it will be able to do a prediction or take decisions on its own. And also that will be without any implicit instructions or any guidance from a developer or a programmer. So we can say that machine learning is a subset of AI. After that, if we trying to handle a bigger problem, machine learning will have a little bit of limitation. And also now we have faster connections, so we can give it more data to be trained on, but machine learning won't give us more accurate results if we give it more data. So here where deep learning come to picture. So machine learning depends on something called neural network. So if there is a problem, it keeps propagating till it find the best output. In deep learning, it uses something else called artificial neural network. So it's you can see a presentation of it on the right side, and if you can see, there is a hidden layer in the middle. So this layer is actually a multiple layer or a collection of layers that will do more computation to make sure that we have better results. And this is very suitable for speech recognition, computer vision, because it's trying to model how people, for example, see stuff. So it can model the interaction between light and sound to figure out how to make the machine see. So if we, for example, have an apple, In machine learning, we will give it a set of specification of an apple, so it's not completely round, and it can be red, it can be yellow, and it's a food. So for machine learning, it will find out on its own if we give it a specification of another object. It will be able to tell us if this is an apple or not an apple. So with deep learning, we can take this even one step further. So we can give it a different type of input. For example, we can give it a drawing of an apple, and as long as we trained it properly, it will take this drawing and it will be able to identify it, extract the specification, and then tell us if this drawing is an apple or not. So there's two main approaches, or the most popular one wants to do machine learning. First one is supervised learning and unsupervised learning. With supervised learning, we are training the model on a labeled data. So we will give it an example, and then after doing the training, it will be able to identify stuff on its own. With the unsupervised learning, we run it on a set of data and we don't give it any labels. So on its own, it can go analyze these data and then try to find a pattern and try to find any abnormality, for example. So it can, if this is banking data, it can figure out if there is a credit card fraud. If it's an insurance company, it can find out if there is any claim fraud. Another approach, which is very popular right now, and it's the cool and newest one, it's the reinforcement learning. It's a reward-based approach. So if we, for example, if we have a car, we can try to let this car, first this car will have a camera, and then that's how it can see the road, and then the car will try to keep maintaining its track on the lane. So as long as the car is in the lane, we can keep giving it positive points. But if it move a little bit right or left, we will start giving it negative points. The more it diverts from the correct path, we will give it a bigger negative number. So if you ever heard about a game being beaten by, or a person being beaten by a machine, for example, Go game, where a machine was able to beat another human being in playing it, that was using a similar approach. There is also a cool way, if you want to try this approach, it's because it has a camera, that's how it's dependent on computer vision. And if you want to try it, you can try the deep race. It's a very cool event where you can try to play and change parameters online on the Brace website, and then you can deploy your code to a virtual car, which you can see on the right. This can be an actual car. You can order it. It has an Ubuntu computer that the code will upload to it, but on the website you can have it virtually, so you can experience the way autonomous car use computer vision to maintain the correct path. So back to focus on computer vision applications. There's a lot of applications for computer vision, and I just picked 6 of them. For example, for recycling, I found out that whenever we split the waste to, for example, a basket for glass and paper and plastic, I found out that the waste company doesn't always take these containers and move them or transfer them separately. They usually, to make it easy to move them, they merge them together, and then in the facility or in the factory, they try to separate these items using some all mechanical systems. So computer vision allowed these companies to have some robotic arms and cameras that can identify these objects and then move to pick them and separate them. So it's better to recycle them that way. Banking, if you ever try to deposit your check using your mobile app, that's also a use of computer vision, of course. And there is also automotive industry, so self-driven car. Not all self-driven car though use computer vision. Some of them use another technology called LiDAR, but computer vision is present there, and it's very promising. After that, there's retail. Best a best example for retail is the Amazon Go store, where they mounted a million of cameras in on the ceiling, and they were able to track each person that entered the store, and they were able to identify the person, identify the stuff they are picking, and then add it to their account. So that was pretty cool. Medical field is also using computer vision, and it make it easy for doctors to identify tumors in brain tissue, for example, in MRIs, even better in early stages. So back to how a developer can do that, and the answer is by using Rekognition service. And here I'm listing 6 of the features it provides. So first one, for example, is the object and scene detection. So let's imagine if I have a photo store, online photo store, and I want to allow people to upload images. So I can use the object and scene detection to identify the objects on the image, and that way I can create tags. So I can store these tags in database or some caching, and then it will be easier for customers to search or look up these images. And then we have the facial analysis. This is a very neat feature. It can identify not only identify people, but it can tell us the age of this individual, the gender, specific features like does this person wear glasses, color of hair, does this person has any facial hair, and it can also tell us about the emotion, the emotional state of this person. So if this person is excited, nervous, fearing something, this can tell us also. Then we have face recognition. Face recognition, it's very cool because if you have one person and we have another image with a group of people, you can still identify this person among the other people, and it will count everyone, and it will tell you how many match it there. One thing to point here though, that this is still 2D picture comparison, so it can be used for security to track people in an image, but it's not advised to be used in authentication. It's still a 2D image, not something like Apple ID or Service Book face login, because the other ones use an infrared, so it can measure the depth of the face, and it's more secure. You have to print exactly a 3D printed face to fool it, but this one can be fooled by a picture. But the main reason for using this one is to be able to identify people in certain images. After that, there is the unsafe image detection. So this one back to the photo store solution. So if we are allowing people to upload some images, we need to make sure that these images are safe. So this will, we can see if it has any sign or if it has a logo for like a company that we don't want to upload it for any copyright issue, or if it has some adult material. This will tell us, it will tell us this is not a valid or not a safe image. So we can flag it or return it to the user. Then we have celebrity recognition. This is a very fun feature. So you can upload an image of any celebrity and it will tell you who that person is. And it will also give you an imdb.com URL to the bio of that person. And I read somewhere that if you have a Fire TV, there is an X-ray feature in Fire TV. So at any time while you are watching a TV show or a movie, you can get a detail about all the celebrity on that scene. So I read that they don't actually store frame by frame, but they know it on the spot by feature like this. So if you want to apply this to the photo store solution, we can check if the uploaded image is a celebrity or not. So if it's a celebrity, we can sell it on our website, for example. So maybe we can flag it or tell the uploader, do you have a copyright? And if they have a copyright, we will allow it. Last one here, we have the text in image. So this allows us to not only do an OCR and recognize the text on an image and extract it, but it also can be combined with other services like Comprehends, and it can be more intelligent to not only extract the text, but also make sense of that text. A recognition service, it started with image, but then it also added a lot of cool video features. So it's similar to the same because, as you know, a video is a set of frames. So usually like 30 frames per second, 60 frames per second. So basically it's taken these frames as pictures and analyze one by one. So we still have the object and activity detection. We still have the face recognition. But the cool thing here, you have the person tracking. So if you have a video with a person inside of it, you can give it a static photo and it will look for everywhere in the video where this person is, and it will tell you. So one cool application for this one was trimming everything, all the scenes that doesn't include this person, and combining them in one video. If you're interested on like doing a party and want to have a video of all the events where this person was in. And we also, another cool one is the real-time live stream. So for this one, you can combine something like kinesis and recognition. So you can in real time analyze images and get identify people in these live stream. So if we want to implement the for store idea, so there's two ways to do it. So here you can see we are using Amazon S3, so we can do an application or a mobile app that take a picture and then upload it to S3, and that will trigger Lambda. So Lambda will Lambda function will communicate with Rekognition, identify the image or the extracting the tags on it, and then it can be stored in a database or an Elasticsearch. So then any other customer, when they come over and try to look it up, they'll be able to find it quickly. So this is one way to do it. On AWS console, we will find an example, a good example for this one in Python. So today I wanted to do something different, and I'm using the SDK. So it's even more easier for a developer to use this one. The SDK is available for different languages. It's available on .NET, Java, Python, Node.js. So, and in addition to the downloading SDK and add it to the solution, you will need to have an AWS account, which is free, and you need to create an IAM account, an account role. And you can try this for free because AWS will give you up to 1,000 image per month to analyze for free. So in today's demo, we will I'll show you 4 of the features: object and scene detection, face recognition, celebrity recognition, and text recognition. So you'll be able to download the code from GitHub. So here for the solution, I have an Angular front end, and for the backend, I'm using .NET, just because I couldn't find any example online on .NET, so I wanted to play with it with the SDK. And so here I'll start with the with label detection. So let's upload an image. So you will notice it's very quick, and it can get you the results very quickly. And this image, it's not a high quality image, so that was part of the fact that it's fast. And but it is also challenging for a face recognition or a computer vision model to understand if it's in a bad quality or a low resolution. But we can see here that it was able to identify it. Okay. Here you can see these. I was able to get tags, and the number you're seeing here, it's basically AWS are telling us how confident that this label is true and valid. And you can see here these rectangles. The colors doesn't matter. I just added random colors just to show you guys that it was able to identify these parts. And I'm not getting all the labels, so see it's not catching the glasses. It's not because it couldn't, but because I limited that, and I'll show you when I started demoing the code. I'll show you about that. But yeah, so here if we go to the output, we'll see here that it's given us JSON with, for example, here we have the wheel. So everything will have a parent. So in this case, it's saying it's a machine, and somewhere else it will say a vehicle. So it's all the related object that this can be, and here it's bicycle. So it's also given us bounding box. So this is how I was able to draw these boxes. So it will tell you the coordination, so you can put this rectangle. And also it will give you the confidence, so how confident that is. And you, in the code, you can make it discard or ignore anything that doesn't match your minimum confidence requirement. So next thing here is compare faces. So the first time I did this demo, it was right after the Avengers Endgame movie. So I decided to use the cast member photos to do the comparison. So here, let's try to test it to see if it will be able to identify a person in a group. So here I have Robert Jr. and a group of other members of the cast, and you will see here it was able to identify him despite the fact that the lighting is different. So here it's a little bit brighter, and also the face angle is different. If you ever worked with OpenCV, this is this is very easier to do it without involving any like particular configuration or any try and fail. So here you can see it's given us how many faces it found and the total of the number and of this group. And it was funny that it was even able to pick someone in the background that it wasn't, I wasn't able to see. So the payload or the outcome here, it's a little bit different from the other one. So we'll see, we still have the bounding boxes. So that's how I was able to draw these images. And then we have the confidence. So this one is very high confidence. And then we have more information. So we have eye, the left eye, right eye, the mouse splattered, and the nose. So it's returning this as well. So if you want to create a cool app where someone can upload an image and make everyone wear sunglasses, you can find where the eyes is and position the sunglasses. So this is the first test. So let's try something else. Let's try if there is someone with a beard. So basically, it's someone with not doesn't have all the face visible because of the facial hair, but we can see here that it was able to identify it also without no problem. Despite again the lighting and the face angle, it was able to identify Chris Vance here, and again it counted the people correctly, and the confidence is a little bit, or the similarity is a little bit less, because again, because of the lighting and the angle, the face angle. But here it's just telling you that I'm confident that this person is the person you are looking for, but the similarity might be is different. So another test we can do here is let's do something with sunglasses. So I'll try first with non-challenging image. So I have this image for Scarlett Johansson, and she's wearing glasses. So it took a little bit longer. It's not because of the because of this image has a lot of, it's a high resolution image. So it basically has more pixels and it needs to examine more data. So that's why it taken more, but it was able to find her here without any problem, despite of the glasses, the lighting, and the noise in the background. And this picture is perfect because of the lighting at the face angle, but again, the glasses can be tricky, but it was able to find it. I found another image though, which is really challenging. This image was from the Captain America Civil War movie. And if there wasn't a caption, I would have not known that this is Scarlett Johansson because of the face is a little bit cut out and the glasses are big. So I wasn't sure if it going to be able to identify her or not. But as you can see here, it did identify her. But again, if we go here, we'll see that the similarity is dropped down, and it is still confident that it's her. So that's good. Another test I can do here is with Chris Evans. So you can see here that his face is mostly hidden. So I thought this would be something challenging for Rekognition to do. So I have here Captain America with a beard still, but again, different lighting and with the full face. So looking for this one, you'll see it was able to identify him as well. So it's very interesting and very capable tool to use. So moving on, we have the image on text. So here we have I have a receipt that I found online. So if we upload this receipt, it will take a little bit more for text, but we can see here that it's able to pull out prices and items on this receipt. The response is a little bit different, of course, and we will see here that it has everything. It still have a confidence rate, and it has a bound box, and it have a polygon. So the reason it has a polygon because it doesn't only recognize computer printed font or text, it can also identify handwriting. So if someone is writing something and they are not sticking to the line, so with the custom shapes like this, it will allow you to find out where the text is located exactly, so you can still draw something around it. I was lazy here, so I didn't circle it, but you can certainly do that. Now, the last thing is the celebrity recognition, and this one worked well, but not very well for me. So here I'm uploading this image, which is again a perfect image because the lighting is good and everyone is facing forward. So here you will see I was able to get all their names. And if we take a look at the payload or the response here, so again, it's given us bound box. So that's how I was able to draw them and landmarks if there is any background or something. And in this case, it's the face features. So we have the eye, so similar to the face recognition. But in addition to that, here it's given us the name of the person or the actor or the actress. And then it's given us the IMDb URL. So that's interesting as well. So now back to the problem I found here. So you will see here, Mark Raffaello was identified here perfectly, but I tried with another image where where the lighting wasn't that good and the resolution was very not not very good. So you can see here that it wasn't able to identify him. But other than that, I did a lot of testing, and it was really perfect. And when we tried the compare faces, it was able to identify his face. It just didn't match him with the IMDb database. So I'll go quickly over the code. There is not much to cover because, again, I'm using the SDK, and the whole promise is it will be easy for a developer to pick. So as you see here, I'm using Visual Studio with .NET, and as I mentioned, I was able to download it here. So depending on the language you're using, each language will has a package manager. So so in this case, because this is .NET, here I have Nougat, so I was able to download this from Nougat. It installed it for me and everything needed with it. Then I'll go over the two of the classes, but most of the others are similar. So here you can see this is a Rekognition client. So I'm just injecting it here and I'm getting this one from the SDK. So so it's as simple as this. I'm just calling this, sending the data, and I'm sending it as bytes. And then here, this is the request I'm doing to Rekognition. I'm telling it how many labels I want back, and the minimum confidence. So in this case, it's 77%. So here I'm using converting the image to bytes because I want to send the image to be processed directly to Rekognition. But you can also send an S3 object where you can tell it, if you already have this image on S3, you can tell it which bucket has this image and the name of the bucket and the key, and it will grab that image from the S3 bucket and send it to Rekognition for analysis. So this is the face comparison, and it's fairly the same. The parameters maybe a little bit different. We have source image and target image. So this is the image that had the person, and the other image that had a group of people. And as the SDK is very well documented, so it's very easy to use. And there is a threshold. So if you're familiar with computer vision, there's a lot of parameters you have to supply, and this is one of them. Here you only needed to provide this one only. You don't have to take care about like changing the colors of the image, graying out, or anything. You can just give it this percentage. So that's all what I have for today. Thank you everyone for sticking around with me, and feel free to reach out if you have any questions. I'll also be available on Slack if there is any question, and feel free to download the code and give it a try. Thanks so much.
Thanks so much, Mena. Really appreciate that. What a great way to finish out the day. Really, really cool stuff there.